Good afternoon, and welcome to the session for Power Apps Component Framework. I know it's just after lunch, and attending a session for pro code for a low-code platform sounds just right. So welcome, and I hope all of you have something to take away from this session. So before we start, I want to reiterate our goal for Power Apps, which is to empower every developer to do more. So whether it's a citizen developer who has never coded, or an IT developer who have some exposure to code, or whether it's a professional developers. So in this session, we are going to focus on IT developers and pro dev scenarios. So this sounds little interesting, that how a pro dev can help with Power Apps, which traditionally have been only something for the low-code developers who can drag and drop and build controls. So let's do it. Agenda for today is I'll give you a brief introduction for the framework. We'll have a demo from Russell, and he'll speak about how Chevron has been utilizing Power Apps and especially Components framework to build their own custom user experiences. I'll show you how easy and quick it is to build a custom component as a developer, and how our tooling facilitates that flow. And the last one, with a demo, I'll talk about the timelines and availability. So to start with, in our Power Platform family, we have few products: Power BI, Power Apps, Power Automate, formerly Flow, and Power Virtual Agent. And from data and intelligence perspective, we have support for connectors. Today, we have around 265 plus connectors, and you can write your own if you want to get data from a different source. Plus, you have the intelligence capability provided natively by the platform, and we are adding more and more to it. And the last one is the Common Data Service, which is enterprise-grade backend for all your services. So it's not just the database, but it provides business logic, extensibility, plugins, connections to Azure, security, you name it, and all those capabilities are provided as part of CDS. And in this session, we are going to talk specifically about Power Apps and how Power Apps Component Framework gives professional developers ability to extend that platform. And possibilities are limitless. All the services, whether it's from Microsoft, external services, third-party libraries, third-party IP, anything which can work on a web client, you can bring it to Power Apps. And that's going to be the game changer. So before we start, I want to see a quick show of hands. How many folks have heard about Power Apps Component Framework? Wow, that's great. Last time I had this session at Ignite, it was like 5 people or 10 people. So that's great. And how many people have actually developed a PCF component? So next time I want a lot of people to go ahead with that. It's very simple. So if you install the tooling, probably it will take 30 seconds for you to build a control to get started. And from there on, you can add more complexity to it. So what is Power Apps Component Framework? When we started building our apps for Dynamics 365, and they were reimagined, we needed a way to build components which could work across multiple form factors, across multiple devices, in a configurable, metadata-driven way, so that as an engineering product group, we invest in something which scales. Our engineers don't have to deal with a different implementation on Android versus iOS or Safari or Chrome or Edge for that matter. So we started building a framework internally which facilitates all our first-party developers to build components which can be used by different Dynamics apps. And as we matured that, added support for ALM, lifecycle control, versioning, upgrades, bundling, all those things were now, they were planned to be exposed to third-party developers. As of now, we are already GA on model-driven apps, and this framework you can use to create your own custom component. And the advantage you get with building a custom component is that it seamlessly participates into the lifecycle of the entire app. So it is the way the first-party controls work. That way, from the component load perspective, configuration perspective, everything is at par with out-of-box components. When the page loads, unlike web resources in the past, it's not when the page loads and it will start loading the web resource or fetching the data from the web resource. Natively, it provides all the data to the control as part of the first load. You can configure it. So the control is reusable. So every single custom component which you build is configurable, metadata driven. So it cannot be specific to certain entities or UI. In addition to that, we give first-class access to CDS backend because CDS is where everything plays really, really well. That's our core backend. And from performance perspective, configuration perspective, everything is super optimized in CDS. So you get APIs, which facilitates you to create a record, retrieve record, or call custom actions with just one line of code. And professionally developed controls can be shipped as part of solutions. So that's the way which has been there for CDS to ship your own custom components, and you can bundle them in a solution and give it to either put it in your prodor or put it in app source so that others can use. So one more thing we have started focusing on as we started working towards having the Canvas apps as part of the CDS app type. The framework was, we started doing engineering work to make the framework available on Canvas app, because one of the things we realized very early on was that end of the day, if a control is to be used by either a citizen developer or a pro developer, whether it's in the model app or a Canvas app, fundamentally controls they are having a large overlapping set, right? If it's a slider control or a text input control or number control, currency controls, these are like bread and butter for a lot of data entry scenarios, right? And it doesn't really matter on how those components were built. So we added the framework support to the Canvas app. We started building the components which could be used on both the sides. And from the very beginning, it was the goal that once you build the components, it should be seamlessly working on both the app types. So as a user, customer, partner, ISV, developer, you don't have to build two controls for two app types. Once you build the control, just drag it, and I'll show you in the demo, and you can use it in the app. Another thing which we started hearing from our customers and partners was that today you have to make a choice, model app or Canvas app. And both the sides have their own benefits in terms of pixel perfect UI, drag and drop, composition, connectors versus pre-created UI, easy to configure forms, and all the capabilities on the model side from extensibility. And this was, in some sense, it's a hard choice, right? And a lot of time people realize down the line that maybe the part B would have been better. So some of the things you can do today, like embedded Canvas in model, will facilitate calling connectors, having the Canvas capability into your model form. And what we have started doing from our side is that building a common layer and introducing a concept which goes away from app types and is more geared towards building components which are common. So we are moving towards a component ecosystem with PCF or Power Apps Component Framework, which is out there already. Today, you can build a component which works on both the sides. You build something, drag and drop in Canvas, resize, add properties, or copy, paste, and use with Canvas components. Same component, you can use it on the model side. So that's there today. And as we release further capabilities there, the goal is that it should be at par on both the sides. Another concept which we have started working on is the concept of a custom page type, where you can drag and drop components from both the sides. And you don't necessarily have to worry about whether it's a model construct or a Canvas construct. Apps can be built using this new custom page, and you can drag and drop either the Canvas components or the ProDev components. And from users' perspective, end of the day, it really doesn't matter. End of the day, if a code is running, it has to be a pro code. Either you do it, or Microsoft does it, or our app team do it. But for a user perspective, it's a component which is available on the Canvas, and it should be easy enough for him to drag and drop and not necessarily know the difference on how the components is developed. So what kind of components can you add? So it could be something simple as field control. Instead of seeing a budget amount as a number, maybe I want to add an arc knob for it. This, by the way, is one out-of-box component. You can just go and configure it, say, arc knob, and it's as simple as that. And you can make a choice whether it should show up on mobile device, tablet, or browser. Because a lot of time there are scenarios where you want to build controls which are specific to mobile, controls which might use the mobile capabilities, right? So that flexibility is there. You can replace the entity grids, home pages, with your own custom visualization. So maybe for appointment, a calendar is a better view, and I want to make it a default view, at least for my appointments. Having that flexibility to define and configure a data set at view level is something which is provided out of box. The next one is unbound control. We don't have a full-blown template for unbound control today, but you can definitely go and configure it or dummy bind it to a bound field, and the control will show up as an unbound control. You just don't need to push the value back into the system to save it. Business process step is another interesting one, where a business process drives how your business is work, or action as a salesperson or a field manager I need to take, and you can pull in these custom components in the business processes. Or you can use services or UI from external services like LinkedIn, Power BI. So within my Power Apps, I can have a LinkedIn profile for the contact I'm doing. And a lot of these scenarios are very straightforward, simple. Once you spend some time building the components, it's mostly embedding that content and passing the context so that right record or UI visualizations can be shown. And I'll show you some demos for that. And the last one is you can utilize the external services. You can go call Azure Cognitive Services to take a picture, convert image to text or voice to text, and we have lots of controls out there, which are already open sourced, and you can take a look, maybe just pull in and do minor modifications if needed, and you can start using them in your system like within minutes. So this is what our UI looks like for Dynamics CE side. And once you configure the custom components, you can totally change the look and feel for the entire app. So this looks a totally different app. Here, the emphasis is on more visual part. So I am kind of trying to show how visually things can be changed, but it doesn't stop there. With plugins, your own JavaScript, custom libraries, you can do a lot of interesting work. And the kind of components I've been seeing over the last 6 months, they really, really amaze me. People have used capabilities like SignalR to do real-time messaging between two people using the clients, or showing the presence information. So for that, I'll invite Russell on the stage. He'll show you some of the cool controls Chevron has been building. Over to you, Russell.
Thank you, thank you. Well, good afternoon, I guess it is now. So as he said, my name is Russell Robinson. I work for Chevron as a drilling engineer. Some of you, if you were in a previous Power App session yesterday, have seen some of this, but today I'll be talking about some of the custom components we use in our digitally enhanced well planning tool, which is an engineering application we've developed here at Chevron. So I'll give you a little context of what the tool is, and then we'll go right into kind of a live demo. So as I said, I'm a drilling engineer for Chevron. Specifically, I work in the Gulf of Mexico, just to give you a little bit of context there of kind of the complex work we do. We design wells that are up to 35,000 feet deep, so nearly 7 miles under the earth. On top of that, that's in up to 10,000 foot of water. So very complex work. As a drilling engineer, it's my job to design, plan, and execute these wells. And so as you can imagine, a lot of detailed engineering work goes into it. On the left here is kind of how the engineer currently does his workflow today, which is a lot of different tools, processes, applications. If he has 12 things to do in a day, he's probably using 6, 7, 8 different tools to do it. On the right's how we've reimagined the workflow as a single user interface. We've said, what if we could instead have an engineer go into one application and do as much work there as possible? What kind of capabilities would that unleash? And so fundamentally, that was the original concept of the tool. Taking it a step deeper, on the right here, you see some of the common design steps that an engineer will go through when planning a well. For each of these steps, an engineer may take data from multiple different sources, and he might do thousands of different tasks or calculations. Now, the complexity occurs in that many of these steps are interconnected, right? For example, the outputs for the fluid design step, shown in orange here on the screen, are fed as inputs when an engineer is doing his casing design work, which is shown in purple at the bottom. Now, once he does that work scope and those calculations, those outputs are then fed as additional inputs for fluid design work. So as you can imagine, this creates a lot of rework, a lot of iterations, and ultimately a lot of non-value added time to the engineering process. We've been able to eliminate or deconstruct that complexity by utilizing a central data core. Now we enter data once, and then data can then be shared in all the integrated tools and processes. So fundamentally, that's what the digitally enhanced well planning tool is built on. It integrates and streamlines the well planning process through that central data core. So that's a little back-end information. Like I said, I'm not going to go too much into the tool and demo the overall because we want to talk about components. So let's go there, and then I'll show you guys a demo. So what were the drivers behind utilizing custom components? As I said before, we built an engineering application where engineers were working in their daily lives. Many of the tools we built were actually integrated calculations, so they were engineering formulas being built in. But one of the feedback items we got, and one of the challenges that were very, very prevalent to engineers adopting it was, hey, we love the fact that we have all these calculations, they're all integrated, you can change a data point, it updates a whole bunch of downstream fields. However, it's a black box to us. We have no concept of how the calculation is being generated, what the variables are in play, what inputs feed it. And so they said, hey, it's great, we have all these fields, but they're just fields. We can't really use it, right? And so that was the first challenge they gave us. The second one was, hey, we love the fact that, once again, we can enter data once, and then data is shared and connected all throughout the process. But with that, there's a lot of complex data relationships that we can't identify. We don't know if one field feeds 5 fields downstream of it. We don't know if another field feeds 25 fields downstream. We have no real ability besides changing a number and clicking on a whole bunch of forms to be able to see kind of the cause and effect of the data relationships. So that was the second challenge. The third challenge was just navigation and ease of use. I think this will be a lot clearer when I show the program, but this was all around being able to very quickly and easily jump around to different forms and fields. So that was from the user's perspective, and so that's where I'm coming from, the engineer's perspective. The other case for change was really, one second here, sorry, was around the developer side, right? What challenges were they facing on our developers or our pro developer side? And a few things there. One was the pure number of fields. We weren't talking about doing some kind of customization for 1 or 2 fields. We're talking about doing it for 50 to 100 fields over and over again. So we needed something that we could build once and reuse. Similarly, we need something that was sustainable and supportable across the life cycle of the tool. We needed something, and I'll show you, that could be kind of self-documenting, which I'll show you in a second, and being able to be used as we expand and adapt the program. That way we don't continuously have to have pro developer support. Somebody even like myself, as I don't even consider myself a low-code developer, maybe a citizen developer, or whatever I am, an engineer could even go and apply it if I wanted to add new fields. That capability can then be used over and over again without a continuous need for that pro developer support. So those were the reasons behind going there, and now let's go into a demo and we'll talk through each of these points a little bit more. Very good. So here on the screen you see the application. Like I said, I'm not going to go too much into what the tool is. I did that in the demo yesterday, but first I want to switch over just to give you some context of what our engineers were used to working with. As I said before, we had a lot of calculations. Sadly enough, a lot of our tools we were using were just custom Excel sheets, right? And this is an example of one of those sheets that our engineers were working on. You can see here, all of these are different inputs. Many of actually which are redundant over and over again. You have another page for inputs. And then they were used to looking at these other screens where there were some calculations. You can't really tell what's input, output, where the answer is. As an engineer that's used it for several years, I could figure it out, but a new engineer would have really no ability to quickly see what this sheet really meant. And so you can see, from a perspective of an engineer, they were used to at least some basic form of kind of traceability of calculations, right? You can see here, you can click here, you can see what the input is. There really isn't, though, very good description here. You can see what the calculation is, though it's, once again, very kind of granular and not very clear, right? So over time, you could figure out what the tool was doing, but really, we challenged our engineers and said this was somewhat of a black box as well, just less of a black box. So this is what our engineer was used to seeing. I just want to give that as a perspective, and that way as we go into what we've built, and you can kind of see the changes that we've made. So I'm going to click back over. That same sheet, by the way, is now a single kind of form that an engineer can see. And the first thing I want to call out is there's two custom components on here, or custom controls. And they're very clearly annotated by the color, right? There's the purple ones, which are our calculated fields. These fields have logic or formulas behind them. They're not editable. And then the second one was the green fields, which are essentially the user input fields. So just from right off the bat, something as simple as color lets the engineer know on the screen what fields he needs to fill out and what fields are going to be the answer or the result and where there's logic. So that's something small but very powerful, because when we first got this application, it was just a bunch of fields. The user had no concept of what was a calculation, what was editable, what they needed to fill out. And so that was a cool a quality that we could build into the framework very easily, or the component. So as I said before, let's actually look at one of these components that we built. So to start, I'm going to click into, and I'm going to show you what the component does, and then I'm going to show you the back end and kind of how easy it is from even my perspective as an engineer to apply to other fields. So here I'm going to show you one of our calculated fields. And on here, there's going to be two kind of tabs that are prevalent to an engineer in the component. The first is the variables. As I said before, an engineer didn't really have a perspective of what variables were going into the calculation. So with this, it's pretty cool. You can see the different variables, and you can also see the real-time value of what that variable is in the equation. So if somewhere else gets updated, this value will also get updated to show the new variable. And within each of these variables, you can also actually click and expand and see the different logic or equations that are being used to generate that singular variable. So that's really powerful as well. So that's from the variable side of things. You also have kind of the overarching formula, right? This is kind of the formula that's finding all the variables and putting it together. And once again, this might not look like much, but one of the cool things that I said is it's a sustainable solution is this is actually self-documenting. And to show you that, I'm going to actually click over into the custom C# code that was developed for this calculation. So this equation is actually pulling directly from the back-end C# code. So it's not that any of this stuff is, say, help text, right? This isn't an engineer or a pro developer going in and writing some actual words. He's pulling the actual kind of equations and codes in the back end and the logic directly into the component, which is really powerful, because in the event that these equations get updated or changed or edited, which they will over time, the same component can then grab the new values and the new equations, and there's no additional kind of pro dev support that needs to be happening. And so that's just, I think, another cool feature that was kind of shown here in this component. And then the last thing is the downstream, and I'm actually going to click into the other component to show you that. So as I said before, the other challenge users came to was, hey, we love the fact that all these data fields are connected, but we have no context of what the data relationships are, right? What the cause and effect relationships are. So for one of the user input fields, right, so these fields are going to feed other calculations, we've given the ability now to click on that and show all of the connected fields that are, so this field will feed all of these fields you see on the screen. And on top of that, we actually have different layers of data underneath each field. So this field, casing pressure test, for example, actually has 3 different sections of data that are prevalent. And so you can actually expand out and see kind of different levels of data that each field feeds. And then the last thing that we built kind of iteratively over time was, okay, now can I quickly navigate to that field, or do I have to go look around for this field? If I make a change, can I quickly go see the effect on another screen? And so the component, you can actually click and you can open that same field. So I just clicked on the casing pressure test from the 16-inch kind of liner, which is a term we use for our different sections of data. And you can see here it pulls open there, and you can even open that now and see the different equations that feed it and things like that. So kind of very powerful kind of ability for the engineer to see a lot of very detailed information about the calculations and kind of the inputs and the outputs that they're feeding. So that's from, like I said, a user's perspective, what the component brought to the table, right? For the engineers, for me. Let's talk a little bit about how easy it is from the kind of the low-code developer's perspective once a pro developer does it. So everything you see here could quickly be developed by our pro developers because they could use any kind of standard web technology that they're used to, right? So the stuff you're seeing here was developed in TypeScript and HTML. There was some styling done with CSS. And so that they very quickly were able to generate these. And once they did, it becomes just another control or another default component that anybody can apply to the form. So I've opened up kind of the advanced settings in the back end and looking at the form. I believe the view of this is changing soon, but I'm still using the old view. And so I'm actually going to pull open that same field, that mop from OpenHole that I showed you that we had an equation for. And we'll show you how easy it is once it was developed by our pro developer to apply. And so you can open this up and you can go to the controls tab and you can see here there's two controls here prevalent. The one that I was showing you in purple is called calculation details. And you can see here it's applied to my web and actually to my phone. So these same controls work on the phone or the tablet, but right now I have it just applied to those two. And so it's already been applied. But in the event that it wasn't applied or I wanted to switch the control, I could just say add a control, and now within all the default controls and components, there's going to be two that I know are the custom, right? There's the calculation details, and then the green component is also called decimal details. And so if I wanted to say switch it to the green component or the decimal details component, I could do that, click to web, or say I wanted that just to be the tablet, and I could say OK. And now I could republish it, and it would be there in real time with the new, the new component. And so that same capability is there. If I want to say add another field, I could drop another field on, apply it to that field, and off to the races we go with that. So that just shows you kind of how really this all came about when we went to our development team and we said, hey, we're having some barrier to adoption, right? Our engineers like the concept of the tool, but in reality, it's not really usable. And in very short order, 2-3 weeks, our pro development team from EY was able to come back to us with a really powerful solution to our problems, and really was kind of wowing our users very quickly. They're like, hey, we didn't know you were going to solve that problem for us that quickly, right? So that's a testament to how flexible the system was and how quickly and easily we could apply it to our solution.
Cool. Thank you. Thanks, Russell. So it was great, right? Something as simple as colors. One wouldn't imagine, colors from developer perspective. A lot of time they don't click. But if visually simple things like color, one of the popular component in community which was developed was just to have color-coded rows or columns in a grid, and people really loved it. And there were iterations done, like I could configure it with a regex expression which would drive the color. And this is something which really connects with end users. So starting from something very simple as color coding something or giving these base values, because end of the day it's just HTML TypeScript. So that was our goal, right? We didn't want to introduce any proprietary language where there is a barrier in terms of learning something new and then trying to adopt the framework. It's standard web technology. So TypeScript, JavaScript, if you are familiar, you can write hello world in HTML. And I'll show you in a moment, you can write a custom control. So that's the place where you start. And from there on, iteratively, you can go as complex as you want to. So at a high level, framework provides you APIs from the system, which deals with component lifecycle. So if I am a component, there is a call for init, which initializes the control, right? We pass you certain objects in initialization, like the context object, like what values this control is bound to. In his example, it would be like the number values for which the detail need to be shown, right? And the second is a div element where you render your UI. So there is a space allocated for the control. all the HTML you are adding to render the content goes as a node in that dev. And from component definition perspective, there are a few things which we really require. One is the manifest for the control, which is auto-generated by tooling, and I'll show you in a second how quick and easy that is. But the manifest dictates what is the name of the control, what is the namespace of the control, right? Things like these version of the controls are needed for enterprise grade controls, right? It's not something which I just need to show and work, but we need to support it, release over release, upgrades of the control, newer version, dependencies, collision with different publishers, right? I might say my slider control and there might be like 20 other slider controls, right? How do we isolate them from each other, keeping them within their own boundaries so that they don't interrupt with others? So that's all that stuff goes in manifest file. And we default all these values. So if you just give like it's a field type control with name my Hemant's control and my namespace is my namespace, we get you started. So we generate the XML for you and you can quickly build a control. But from there on, as you start doing enterprise development, you can go and modify all those knobs and properties which are out there. The second one is control implementation. So since it's a pro dev experience, the index.ts file is generated for you. It has all the right methods. As I said, init method or update control method or destroy method. These are the ones which are like needed. Rest of them are optional if you want to use, sure. Otherwise, it's not something which every control would need. So you are provided with a skeleton for this class. Even if you just compile it and install it, it's a working control, right? So that's the implementation of the control. The third one is resource file, right? A lot of time controls are not a standalone entities, right? They would have dependencies. I need to localize it to 47 languages, for example, or I need image files to show up in my controls, and I'll show a demo for that one too. So all those dependencies can be added through the resource files. And we have GA'd the CLI tooling for component framework, which enables developers to build the controls, test them locally on debug harness. So that was one of a big feedback from user that once I build the control, I have to install it, publish a solution, go to a field, configure it, publish it again, and then see it, right? And oh, there is a bug. Again, repeat the process, right? So one of the core advantages which CLI tooling provides is that on the client, without a server at all, it can boot up the control and you can see it right on the client. And with the capabilities we added over time was something which would really increment the dev inner loop. So as you make the changes, it will automatically compile the changes, and in your browser, you will see how control is responding to it. So I'll show you that too. Let me switch to my demo machine there. So I have my CLI tooling installed on this machine. PAC, Power Apps CLI, PCF init is the command. So I just run this command to see like what are the parameters. Sorry, the font is really large. All you need is name. So let's say Hemant, namespace, and template. So let's say it's a field type of control. So that's all is needed. I already have a working control. It initialized everything. And to show you that, I will open it in code. Give me a second. I think, give me a second, let me, font. Increasing the font last minute was not a good idea, so let's try it again. PAC, PCF, init, and it says PAC, PCF, init, minus namespace, test, minus name, template field. So what I'm doing here is PAC, PCF init, template field. Something is bad with this one. Okay, let me switch to Ignite demo. there. This one has a pre-built control. So once I run this command, it's the template which automatically generates, and it has an init method, which is initialization of the control. The first parameter here is the context object parameter, which gives you all the APIs for this PCF control. The second one is the state for the component. So individual components, you can store the state, right? So if you want to store something so that the next time the control loads, the initialization is fast, you can use this init object. And the last one is container, the place where you are going to put your content. Only my code in this file is this. In the container, I add an inner HTML which says font size red, and probably I can say hello here. This will put a red hello in the control. So if I configure it to any control, I'll have a red hello sign there. Or I can do is I can use the context object there, which gives me IntelliSense to select the right object, and then you see all the different APIs available through the framework. So as you code within your studio, you don't have to necessarily look at documentation, but everything is shown to you. So in this case, maybe I can pick device and see what all is present in the device. So I can capture the audio, capture video, get barcode value. You don't have to worry about like how iOS does it or Android does it. You can just use the API and consume that property into your control. And about context.parameters, the values to which controls are configured, they are also available. So if I do sample property.raw or formatted, this will give me the value to which the control was configured. So now this is a fully functional control which would take the value on the field and show it in the red font 4. That's it. So you don't need any more changes than that. You build it and deploy it. The tooling provides you a way to create a solution, package it, upload it to the server, incrementally make changes, incrementally see it in the local client. So all those things are there, part of the CLI. So with like these 5 templatized commands, you can build the control, push it to the server. Let's look at the working example. So here I have a project entity in my system. This is a model-driven app. What I've done is I've configured few custom controls which I have developed, okay, using different services. So let's say my project, and I save this record. This was a quick create form. You can add the custom components to the quick create form too. So one of the benefits which comes with custom components is that you can put it at all the valid surfaces, whether it's a grid, subgrid, form, quick form. Any place the control is valid, you can go and quickly configure it. Okay. Now if I go to projects entity, I can see all my projects. Instead of a grid, they all are shown in a map now. This is a custom built map using the component framework and using Azure APIs. So as you can see, I have all the points in there. So it's not just that I render the URL of the map. All this code is within my custom component. It just calls Azure services, but everything is rendered on the client. I've added additional logic to show my current location, which is pulsing here. For Ignite, I can zoom the map. I added buttons programmatically to make map bigger, smaller, or rotate it left or right. In addition to that, if I go to individual pins, I can see the data from CDS being surfaced. So it shows the title and description. And to add these values, let me open a new project form. So this form has the fields and few more custom controls. Let's do one more demo. Address search. This control uses Azure Maps services to suggest what are point of interests, right? So let's say I'm from Seattle, so we'll say space needle. As you can see, as I type, the recommendations are automatically populated. So what the code does here is it captures the user click, calls Azure services, and puts it back as possible options in there. So if I choose space needle, the point of interest is selected, but I want to do more, right? When I use Azure services, I have the geocoding, I have the longitude, latitude for the position. Maybe I can use the route, right? So Component framework gives you a way to add something to the UI, right? But the platform as a whole has whole lot of capabilities. You can use PBL, client API, expressions, server-side plugins to kind of build the complete solution. So in this case, I've used a PBL. So if I toggle this button, which is again out-of-box custom component, to on, it shows the map with longitude and latitude value and the route painted on it. So this one is another custom control which paints the route from current location to the destination. Let's see how this works in the Canvas apps. So in Canvas apps, right now, you can use the components by toggling the experimental feature on, which is there. The component feature in this case is already on. In this app, I have two sliders which are out-of-box Canvas components, which I want to highlight or showcase how they can be bound. And if you say import the component through import component string, you have these components which are in CDS, which can be imported directly now into the Canvas apps. So I have two already. Let me go and insert the map control for directions. There it is. I'll put it here. Try to resize it a little bit. There. So I have my same map control which you just saw on the model apps. Another thing I want is that this map control requires longitude and latitude. So what I'll do is for latitude dot value. So I'm putting the value from slider, and same for longitude. Dot value there. Let's insert one more, which is using Office UI Fabric control. I'll just drag and drop it here. So this one is to showcase that the Office Fabric UI capabilities on the client wrapped into a PCF control. Now it becomes a PCF control. So let's run this app. So I run it. As you can see, the map route is painted, but since it's bound to these longitude, latitude values, as I change the values, the map route would be modified and updated. So I can change it to different values. Map in the real time during the preview, during the authoring, responds to these values, and these values are shown in Azure Map on the Canvas app. Additionally, I can use this grouped people card control, where if I click, a new person is added. This group, it can delete the users. So that way it gives me an easy way to not rebuild everything, but just include it as a PCF component into the app. And that way, very quickly, just few hours of work for all these controls will enable me to bring a lot of values in the Canvas app. And the reason why it's more important in Canvas apps is because there has not been any professional development story there, right? As we target, 10 million more developers, here is a chance to enable and build these components where they add unique value, and they can be added to the Canvas components. So with that, I'll switch over to my deck. Quick status on where we are. As I said, we are already GA'd on model-driven apps. It's in experimental preview right now for Canvas applications, and within a week or two, we will be announcing a public preview for PCF on Canvas apps. There has been great adoption for the components. We have a very, very strong community which is here to help. So it takes some time to kind of get and learn the pro dev skills for a new framework. But today we have lots and lots of people who have really developed deep expertise and have shared lots and lots of controls. Towards that, the PCF Gallery is a site created by one of our ISVs, Qdo. It has more than 100 open-sourced PCF components. The ones you can go, take a look at the code, you have solutions, build it, and you can put it in your own deployment or your own test environment. You can go modify them. So this has a wide spectrum on what all can be achieved using the component framework. So definitely, one place you should definitely plan to look after attending this session. Here are some references on our blog announcements, documentation. If you have any feature idea, feature request, we are accepting those ideas through our community portal. Just log an idea, so we look at upvotes and try to add them to newer releases. So any questions? I'll take some questions. We have almost the time. Yep. Any questions? Nope. Thank you, everyone. So I'll be here. If you have anything, let me know. Thanks, guys.